before I forget. Perfect. All right, so kicking this off, I think we should start with quick introductions. Some of you may know each other, but very quickly, name, location, what you do, and what you expect from this call. Obviously, I'll start. My name is Arthur Killian, founder of All Crazy Things and the chief creator of craziness. So that's what I do here. Super excited for the call. My expectation from the call is to engage community and see if we can continue running these productively and also learn from you guys. So that's my intention. Daniel?
So I'm Daniel Lindenberger. I'm in Langley, British Columbia, and am engaged in various work. It tends to be shallow but wide, with large language models in the academic, nonprofit, and corporate sort of areas. I'm particularly keen on looking at how it can be used for self-organizing, decentralized groups like this. So I'll probably be skiing with a lot of you on how we can add value to how we're doing what we're doing. So we'll play in a meta sort of a way. I'll throw things over to Anton.
Hey, I'm Anton. I was an early member at Corona Y. I was responsible for some of the technical questions, infrastructure, and what's not. Here, I'm also kind of like in the same role. So anything related to deployment of agents and actually running them, processing data, storing it somewhere, you'll probably deal with me. So yeah, feel free to pin me in the Slack channel if you have questions related to that. Let's do Manuel.
Yeah. Hello, this is Manuel from Barcelona. I'm a Python developer and basically AI engineer. And well, I come from the All Corona Y effort that we meet at Kaggle. And I was called to Julian to come here. And well, happy to know the new faces and also to see the old ones.
I'll go next
And
because someone needs to. Tyler, I'm in the UK, the northern part of it, nowhere near London. For anyone who ever asks that one, I don't really know what I did at Corona Y. Sometimes I was as confused about it as everyone else. But I suppose I was one of the people who tried to understand what all the different teams were doing and tried to direct people to where was needed. And I probably am going to fall into a similar kind of role in trying to understand the high level thinking and the organizational systems more than the hard coding side of AI. Though I am interested in the technology and I think it's going to be a really big impact moving forward. And I'd rather it was done in a sort of an ethical and understood way rather than, only corporations being interested in it to try and make money out of our whatever knowledge and information that exists. But yeah, it's nice to see some familiar faces again. Slava, go for it.
Yeah, so my name is Slava. I'm Ukrainian, but I live in Netherlands, and I also was active member of Corona Y, mostly working on data infrastructure and Dataverse. So I will continue, I hope, here the same data management streams. And currently I'm building artificial intelligence for a few organizations in Netherlands. So I'm very interested in the topic.
Hi, everyone. I'm Chetna Krishnan. I'm currently a master's student in Birmingham, Alabama. So I'm from Corona Y as well, and I'm really excited for this new reunion. I would like to explore a lot about large language models for healthcare applications.
Hello, everyone. I'm Alexei. I'm from Ukraine. We did with Artur before Corona Y some projects, exactly research projects on Kaggle. So I guess I didn't do a lot of some researches about participating in Corona Y project, right? But still I tried, I guess. And now I want to join community, and I'm looking for experience and looking for some transfer researches to practice more, right? Because I'm a university professor and I'm do a lot of researches, but there is some lack of practice with some production and so on. So, okay.
Awesome. Wendy?
Yeah. Hi. So I'm Wendy. I'm from London, UK. I'm a machine learning engineer, and I work quite a lot with LLMs because that's the nature of most of the data that my company works in. So I'm interested in kind of translating the flood of research that's coming out around models into kind of stuff that people can actually use, and how to kind of deploy them efficiently. Yeah.
Vijay, you want to go?
Yeah, hi, I'm VJ. I'm currently a student at UIUC, studying computer science and economics. I was also in Corona Y back in the day. I think most of my work there had to do with the Kaggle notebooks, when it came to um, like processing all the medical papers and whatnot. That one. Um, yeah, here I'm just hoping to learn more about LLMs. It's really exciting, and I'm trying to get better at it and hopefully understand the application in a much deeper level.
Awesome. Tina?
Yeah, hi everyone. So I helped a little bit back in the first Corona Y phase while I was finishing up my second master's degree. So happy to be invited back this time. Thank you so much. Background in business operations and technology projects, information systems, data analytics, and AI.
Awesome. Saptarshi?
Yeah, hi everybody. I'm Saptarshi. I joined Corona Y probably at the start of the pandemic. Then I only had pure knowledge of medical science and biotechnology. But since then, I have upgraded myself to machine learning, deep learning, and lately I'm into this generative AI sort of things. So hopefully, I'd be able to enrich and empower myself through this reincarnation of Corona Y. Thank you.
Amazing. Well, congrats on the upgrading and kind of like shifting the fields. Yeah, that's impressive. All right, who's next? Osama?
Hello everyone. My name is Osama. So yeah, I come from the Corona Y team. At the time, I was in Morocco, and my role was a data scientist as part of the Task Geo team. So some faces are familiar for sure, especially Manuel. And yeah, ever since then, my background is in robotics and computer vision. But recently, I moved to Toronto, and I'm doing a program in applied AI, working more with language models now. And yeah, this seems like a perfect community with like-minded people to explore this field and exchange knowledge.
Awesome. Sushant?
Hey guys, this is Sushant. I am based in UK in Bristol. I'm working as a machine learning engineer. Yeah, I had some great fun during the Corona Y days, and yeah, I'm looking to learn more about some of the things regarding RAG. I do work with LLMs, so yeah, looking forward to how I can contribute. Thank you.
Amazing. Lubomir, is that you?
Yeah, that's me. Hey everyone, I'm Lubo. I'm based in Luxembourg, originally Ukrainian. I'm a data scientist with background in the classical machine learning. I've been working like last 5 years for big tech Amazon. Now that I'm again back to being consultant, and some of my projects involve LLMs and RAGs. So I was interested by maybe the pick of papers for the discussion today. and also I'm interested how this community works. So that's also like a great learning. I haven't been the part of Corona Wire. I was aware of it, but I wasn't part of it. So now I don't want to miss the chance to be part of this community.
Amazing. And I think last but not least, Shannon.
Hi, everyone. I hope you can hear me okay. It's really amazing to see you all again. I was part of Corona Y for a little while early in the pandemic before I just had too many hats to wear and I had to take a step back. Most of the time, I think I worked with Daniel and a lot with Tyler and even with Arthur for a bit. A lot of directing people to where they needed to be and making information come together. I am actually a circuit design automation engineer, so my expertise is not in machine learning. I know a little bit, but not enough to be useful most of the time. I find that maybe not unlike Tyler, my interest in it recently has a lot more to do with things like security, access, and governance. I think some people here know that I'm very concerned with those issues, and I don't know enough. So I'm looking forward to seeing if some experts join who know about those things, and I would like to learn from them.
Amazing. Yeah, what a group. I'm super excited. To be honest, I haven't expected so many of the familiar faces to join in, so that's amazing. Thank you guys for trusting us to create something amazing together. So I'll kick off the agenda with the overview why we picked this topic for the first paper review session. RAG is, I would say, is probably the hottest topic when it comes to application of LLMs in production environment, simply because it attempts to solve the major problem of hallucination and the actual correctness of the generated text. And obviously, agents is another topic that is converging with RAG and almost creates a perfect mix of technologies to explore for these kind of sessions. The papers that we picked for first session, I'll be honest with you, it was actually picked by AI through some manual, some automated actions, and our idea behind the sessions and the community to actually create these tools to help us digest the papers and create the agent that is a continuation of our Corona Y experience. Because we started from the literature review, and this is, in a way, a literature review just for another vertical, other niche. So obviously, we're still super early and there's barely anything created, but we're still, exploring and figuring out how to do this in the right manner. So after this call, would love to, to connect with each of you or group calls to see how we can propel that vision forward. But for the sake of, paper review session, let's quickly do the overview of the papers. So the first paper, Power of Noise. It's an interesting counterintuitive paper that talks about how to order the papers and which papers to actually documents include and the retrieval system in order to LLMs to generate proper responses. Counterintuitive because they introduced the concept of noise in irrelevant papers, which is super interesting. The second paper, RAPTOR, is another, I would say, technique that is based on tree-based hierarchical summarization of the documents. So that seems to be an interesting technique that I haven't seen before. I've seen summarization in general and various techniques that layer on top of documents, but tree-based hierarchical summarization is definitely something new. Then there's CRAG, corrective retrieval augmented generation. Also an interesting technique because it almost like it's an engineering solution. It includes retrieval assessment, the actual expansion, and selective decomposition of the documents. Super interesting. And the last paper is somewhat, it's a survey paper. It gives a pretty good overview of the ecosystem of agents and the basic concepts and pieces that you should be familiar with if you want to attempt to create an agent. A lot of these things we've seen being like formalized in the past year. Since, the first attempts with Auto GPT and Baby GPT, people were throwing around these concepts like memory, the thought process, cooperation techniques, all of these things. And it's a good survey paper that talks about these in detail. And yeah, super excited to have it in here and talk more about it. So as the next step, a brief introduction that we've done through the use of the agent is basically, just something to talk more about the specific papers and talk about each paper individually. So what I would propose, unless someone has a better, engagement mode, I'll start with the each paper, and then we can have kind of a roll call of thoughts and processes. Thoughts and processes to discuss each paper. So first paper, Power of Noise, offers counterintuitive insights about the value of even irrelevant retrieved content. This could catalyze innovative thinking on what makes an optimal retriever and context formulation. And maybe I'll share the screen with the actual paper, just so we have it up here. All right. So I guess the first question is, who actually read the paper? All right. Anton, you want to kick off the discussion?
So I'm not sure like how to kick off properly with the structure, because I have just kind of a number of thoughts on the paper. What I found interesting, because like the whole idea of the paper is that adding noise during like retrieval is actually improves the result in the end for the LLM. And it's kind of counterintuitive. And if you read any papers on RAGs, and some of the papers that we'll discuss later kind of contradict this idea. Everybody talks about like, oh, we need proper context, like building for the LLM to answer questions. So this step of kind of pulling relevant data and all of this, it's kind of like important for that. And all of my thoughts, essentially, whole last year was all about like how you build this context building inference engine from the documents. And now this whole paper talks about like, oh, by the way, if you do it super nicely, the results will be not optimal. And I like that, like the explanation is it's all about like entropy of data. And if it's like too small, you have like the new coin term, like collapse of entropy, and then the performance degrades. Very interesting stuff. I'm more interested to like, so based on this work, now I'm interested to discuss like the topic is, so what can be done to actually kind of like control this entropy of information that is being fed into context of LLMs, and especially from the point of view of topic of like, if you have a knowledge graph, right? For example, like the discussion of the methodology they used and some of the like examples that they walk through, like the kind of like research was they took the papers from essentially Wikidata, perform some experiments, then start adding like, so what do we add? Just random papers, like random documents from the Wikidata as well. So they run an experiment, then they added a data from Reddit, and then the results were even better. So it's all about like this entropy, and I wonder like, like more depth research in this topic. But yeah, that's kind of just a few thoughts of me based on this specific paper.
Yeah, it was super interesting how they introduced this kind of modeling exercise of, the order of golden paper, relevant, irrelevant, and like completely a complete noise. So in a way, I was also like yesterday, I was reading the actual paper, and I got sucked into even more research of finding research papers related to the entropy collapse in LLMs. And it seems like a whole different topic in terms of, what does the actual optimal context like mean? And it seems by this research paper that introducing noise creates a much better selection behavior for the LLM to actually pull the most relevant knowledge from that context. And the things that I'm wondering about is how it all relates to the large contexts, because that's not something that they've tested. And I wonder if the same behavior applies to really large contexts, because when we're talking about books or, you know, giant research papers, like I wonder how much the actual noise helps in those types of use cases. So that's my thoughts. Anyone else?
Two random things that kind of pop to mind, and these are more kind of on the surface level. One, it's interesting to me the way that addition of noise and sort of that additional chaos is very similar to just the simple temperature aspect with a large language model, in that you don't want things to be too predictable, otherwise you get worse results. The other thing that it makes me think about, sort of in an isomorphic way, is decentralized groups like this, and what are the best ways to be able to use as you're trying to build collective intelligence and sort of synthesize the different knowledge that's there. How does that same entropic effect, how do you lean into that in ways that give benefits rather than simply added chaos as we all collide and kind of work on these pieces? So minor thoughts, but there they are.
Probably I will continue. I'm also doing quite a lot of LM research, and what I can say about this paper, well, first of all, about authors. You know, authors are Italians and they have a school, and it's a bit different school from what you have in US, and they're in, you know, in knowledge graph, in semantic web, this kind of stuff, which is not very common in US. And second thing, I think they selected papers a bit in the wrong way. I'm not criticizing the approach, but I think it should be organized on facts level, which are triples, where you have like fact structured in a way that it can be actually evaluated as wrong or true, right? So you can get like 90% or 99% of paper with right facts, and one fact, which is the most important thing about the whole paper, will be wrong, something like conclusion. And you are obviously not going to catch this information by using this approach, because you don't know where noise is, right? So I would say what they should do, they should kind of restructure paper in facts. So all statements should be consistent of knowledge graph. And this knowledge graph by itself will become part of prompt. So if you want to get some questions answered, you should also provide in your prompt, you should provide parts of this paper with some statements corresponding to what is the whole paper is representing. Well, this is of course judgeable, but my experiments show that as soon as a model is good enough, and you can think about like Llama model is being trained on Wikipedia, which is quite a trusted source. So you can get some kind of trusted response if you'll use statements instead of the whole thingy described in the paper. So that's my point of view.
So the good follow-up questions here would be, so if we essentially start implementing the approach just proposed, just to have, instead of kind of like documents feed into the context, but more of a like distilled like statements and everything, aren't we like reducing the entropy of the whole context now, and then technically should even see degraded performance? Because again, LLMs, it has its own thought process, you know, and if it's feed very structured data,
yeah, right, it makes it even more predictable. Yeah,
right.
Yeah, subject to experiment. Yeah,
That's the whole thing. Like this paper is very interesting in terms of this. It's counterintuitive, right? And it explains why this new revolution even works in the first place. Because everybody's like, yeah, we need this still, this. But then in reality, hey, we just have more like more billions of parameters. Like context length, yeah, just like let's increase it more. Computationally costly, yes, but otherwise entropy is big enough, so all of this kind of works. So that kind of the thought-provoking thing here.
If I may add something or like ask a question here. This is Fadi, by the way. Missed my introduction. I'm currently in Doha, Qatar. I was in Beirut at the beginning, and I work in fine-tuning LLMs to care about value systems and for Arabic speaking people. So one thought I had when you're discussing this is that order is important, and the fact that this is counterintuitive suggests that maybe there is a partial order that these guys from semantic web typically like in search and semantic web. Semantic ordering is not always a strict order, so maybe the noise is we can probably suggest that there is a partial order in this data that noise helped the LLM discover when we're traversing the data that it ingested, and because of the noise, somehow this partial order was presented or was discovered instead of going through the strict way of doing the right thing nicely and passing it nicely. Because partial orders are typically hard to discover. The nice order gives you this idea of going through one local minimum to the next, to the next, to the next, and if you're stuck in with the order and your local minimums, then you don't discover the new ones. Maybe the noise is somehow kicking us away to another order.
That is actually a fascinating thing.
The whole paper, but what metrics did they use when they decided this is noise and this is like how did they figure out that? How did they say this is noise compared to the rest of the data?
Embeddings. I think they use BERT embeddings. Okay. Yeah, and you're actually pointing into the thing that I was thinking yesterday in terms of exactly that. Like, let's imagine there is this embedding space, large embedding space, and over-optimization of the context with relevancy pushes us into, one segment of the dimensions that LLM is working with. And introduction of the noise, slowly pushes us away into some other direction that may not be relevant at all, but, in a way points the attention into the other section. So that's kind of like how my visual brain attempts to visualize it.
Yeah.
Lubomir?
I'm thinking, but this means that there is probably a better way to search than just the noise. So if we can find like what is the metric that suggested these are noise, like what did the intuition say, and maybe we can find a better way to traverse the knowledge graph they have, or maybe add the noise nodes into the knowledge graph in a way that is now traversable, and we can come up with even a better systematic way.
Lubo?
Hey, well, first of all, it's an interesting paper. It's the one which spotted my attention the most because it's actionable. I mean, it's very easy to implement the noise to your system, right? But like, I agree with everyone that it's kind of counterintuitive, and I couldn't find a good explanation why. And the only analogy which comes to my head is like the similar to classification models. If you're adding, or at least, okay, correct me if I'm wrong, but we had an exercise when we were like adding the noise to some data. And when we saw the performance improvement of the model, or the noise was actually like some noise features were performing better than some useful feature, which we believe. It came us to like the idea that the classifiers were like overfitting. So would it also signal that maybe the embedding model used might be just overfitting the data? Maybe like the chunks are too small or whatever. So it's eventually overfitted, and it just shows that like it's overfitted to the degree that even noise improves it.
Yeah, that's also a valid hypothesis.
Am I right in thinking that like I'm trying to understand this because obviously I'm not as well read in this field, but is this like the idea that adding inaccurate or less useful information makes the actual accuracy of retrieval better? Is that basically what it does?
Yeah, the actual generation.
So in that sense, my way of thinking of that is like, if a knowledge space is so concentrated and so similar to itself, differentiation within itself is harder because it's like an angle thing. So if you add way more information outside of that, it kind of makes the space bigger, so the ability to focus on the thing that's useful is easier to work out because it's actually increasing the whole space. So like the accuracy is like the requirement for like perfect accuracy between tiny differences is really hard in something further away. But if the whole thing is bigger, it's actually the inaccurate things can still be used as direction points to help you focus in. Whereas if it's like super tight, it's really hard to hit it or hit something accurate. Is that kind of like the way my brain is thinking of this? Is like making the whole thing bigger, it makes it easier to hit it. And as you approach the target, even the bad information helps you find the good information. Is that kind of what I'm thinking? Is that what the intent, like how the principle of it works?
So to me, it kind of like, this is actually a good explanation why this whole thing actually works, because it again, it could be true what Lubomir said, that it's about kind of like this noise kind of works on this before LLM kind of consumes this context kind of overfitting type of situation. We know that noise is a good regularizer, right? So it could help there. But what I think is Tyler's intuition is correct here is when LLM consumes the context and want to output something, one thing, if it's all into one specific space, so everything triggered is the thing that it's hard to distinguish things and find the right path to the answer versus just kind of like, wait a second, here is a bird's view picture that was thrown out by some like noise introduction. And the only thing I don't agree with Tyler's point is the noise not necessarily means like garbage data here. It just simply like this expansion of the search space. I think this was the correct definition.
Yeah, like
then,
increasing the information in the pool. And I'm not saying literal noise.
Yeah,
I'm just
yeah.
saying relevant versus irrelevant. But adding a lot of irrelevant things makes it easier to work out what is relevant because there's actually more things to refer against.
Yeah, imagine the next paper tests the hypothesis of just adding 100 instances of the word noise, and it improves the accuracy.
Oh yeah, like add tips, like right. By the way, all of this could explain why those things work, but then I don't think
Just to
necessarily
reference what Anton is talking about, there was a lot of research recently about how adding things like please, or I will give you a tip, or I really beg you, or my life really depends on it, improves accuracy of LLMs, by times. So yeah.
Right, but what I think is actually what also could happen is this, not necessarily like this kind of idea of expanding the universe. It's just simply, if you ever in your life tried yourself work on some problem and you kind of like stuck somewhere, then somebody shows up like, what are you doing? Like, why I feel like frustrated and etc. And then you go like, hey, I'm working on this stuff. And then somebody will tell like, you know what, there is the same, and they tell you something. And then you kind of like, oh yeah, exactly. And then boom, you suddenly like unblocked. So I think a lot of processes like this could happen within LLMs as well, because again,
yeah, it's like pointers. I
stuff.
think the simplest analogy that we can use is the noise acts as a pointer in this multi-dimensional space. Yeah, pretty much. So that's pretty cool. Yeah.
If I may, like I'd like to rephrase what Tyler said. So when you add more points that are not necessarily relevant to the retrieval, so they somehow are now friends, or they let's say there are 2-3 nodes that we are interested in. These are the ones that we want to retrieve, and they are just next to other points that we are not interested in. When you add noise, those codes that we are not interested in will have friends to hang out with, and the guys we're interested in will be easily showing, will be able to sift them by a prompt. So by expanding the space and giving more points that are probably irrelevant, you have somehow gave company to other irrelevant points that are less ambiguous now, and you see the ones that are clearly relevant because you added the noise. And I don't know if this allows, like, you're adding more background, right? So you're adding more background, and the things that shouldn't come to the foreground will now be more similar to the background. So things that are foreground colors will be visible more. I'm trying to understand what Tyler said this way.
Right.
And working similar to what Anton was saying, what comes to mind is E prime, where I don't know if you all know the language where it's simply the modality of speaking English. I think I'm thinking of E prime, where you simply avoid using E. And so because E is the most frequent letter, you're having to compose weird sentences, and that makes you more creative in how you're doing it. And because, if I understand right, what's happening here with the noises in the articles that are retrieved, which then lead to generation. So you're sort of, I mean, as I think it was you, Alexi, who was saying, if you're widening the problem space that's being sort of pulled from in order to pull it together, there seems to be something interesting that happens there. Again, analogous, but we worked with facilitators who would use a card deck to look at how they would solve problems with different methodologies, simply because it freed them up from their given way of thinking that they would kind of get into a rut around. And it seems like there's maybe some similarity there as well.
All right, question from Chitana. Do authors achieve the same level of retrieval accuracy when the LLM size is changed after noise application? Well, they tried different LLMs from what I read in the paper, and they, replicated the same behavior, if that's what you're talking about.
Okay, got it.
All right. Before we jump into the second paper, Ian joined us. So do you want to do a quick introduction? Basically, name, what you do, where you are, and what you're expecting from this call.
Hi, Arthur. I'm on the east coast of Canada. I've been involved with you and Daniel and likely some others here in past incarnations of this movement. I didn't realize I was unmuted, and so I apologize for the fans that you probably hear in the background, and I'm glad that I didn't say anything inappropriate. I work for, recently I started working for an AI company that our first product to market is a virtual companion with voice recognition, text to speech, and that, an in-house developed LLM and customization. Although we're using 11 Labs for text to speech, but we'll probably wind up bringing that in-house this year because we've got a bit of runway with angel investment. We've been approached by Stanford's AI lab with the prospect of, although what we've built so far, what they built before I arrived on the scene, we've got about a dozen or so people behind the scenes. It's a conversational thing with what they've termed as dynamic bonding, so a way of implementing long-term memory that's human-like, because this isn't meant to be this isn't Jarvis, this is meant to be a human-like conversation, so it's not meant to have the full accuracy in scientific methodologies and that, and we have things like alpha geometry and so on and so forth to look to for designs that can marry with more LLMs with more exacting processes to ensure that there is proof and an accuracy in the findings. So this is meant to cater to the consumer segment, although the Stanford AI lab has an interest in the application of what we've done to serve the autistic community. One of my business mentors is interested in bringing it to bear on other neurodivergencies such as dyslexia, since it can be entirely verbal both ways, but is in the roadmap has us integrating with other things. How it well, yeah, it's seen as a likely candidate for not only business to business stuff, but also helping people with dyslexia and literacy. My mentor's one of his passions is helping people to avoid the literacy stumbling blocks that he experienced in life, being neurodivergent and on the spectrum himself. I've had a lifetime of charitable work, and so I'm on the board of advisors for the One of Us Global Foundation, and I've brought that to bear on my involvement in growth and partnerships with the AI company, and so with that charity and nonprofit element, well, fiber in me, it was just a natural fit to see what's happening here in this space, to see what opportunities there are for us to, for the corporate side of my involvement, to help what's here. And I saw a mention of the prospect of partnerships or leveraging things in the for-profit world beyond what us as a nonprofit here are doing. And so over the past few years, I've been very much a connector of things, and so I'm here to see what opportunities there are for connecting not only what we're doing here with what I'm doing at work, but with the other people and organizations I'm involved in. So happy to be here. Sorry I was late. You don't need to hear about my back problems that cropped up yesterday that had me in bed most of the day. So yeah, I'm here now.
Yeah, much needed. Thank you for joining in. All right, jumping into the second paper, which is RAPTOR. Really fascinating thing because it talks about the tree-based hierarchical summarization. And for those that haven't read the paper, just to give a kind of a quick overview of the core concept. Basically, they propose that by distilling and hierarchically summarizing concepts and facts across documents, you can achieve much higher accuracy when retrieving these documents and passing into the generation. So basically, and they propose two types of retrieval, the tree traversal one and collapsed tree retrieval. In simple terms, let's assume that, you know, at the deepest level, there is like the most general document, and then as you traverse the tree, it gets smaller and smaller and more compact as the summarization algorithm compacts it. So as a result, when you're doing a query, you're actually picking these summaries and traversing the tree, and then using this retrieved content with a query to provide an answer. Or using the collapsed tree by picking, you know, the most relevant documents out of this pool of the tree nodes. So overall, super interesting because it actually tackles a lot of the limitations of the context size, and I can see how the application of the tree-like hierarchical summarization can help overcome those limitations while actually increasing the accuracy. Also, in a way, as a byproduct, I think it solves for another huge problem that people stumble upon in production environments, which is the existence of knowledge across different chunks that may or may not be in the pool of the top K documents that the retrieval retrieves. So, you know, for the research purposes, people, you know, don't research this topic as much because for these over-optimized, you know, let's say benchmarks and data sets, even multi-hop Q&A data sets, people don't have much attention towards these type of use cases where the knowledge can be in one sentence, in one chunk, you know, in other chunk in one sentence, and it's so like split between different chunks that when you do top 10 documents, you know, often miss out on some important information. With this type of technique, if you summarize things properly, hierarchically, in theory, those, let's say 3 chunks and knowledge that is scattered around the document will eventually lead to a very dense, compact summary that will include those facts. At least, that's my hypothesis based on reading the paper. But yeah, would love to hear your thoughts.
So I have a question about like the traversal thing. So is it that you kind of basically like say at the top level you store the titles of documents, and then the next level you say one, I mean kind of like how do you make sure that, like how do you split it into different levels, as in what's the representation of say a higher level?
From what it seems, the hierarchy is the level of compression. So in the first method, you just go deeper into expanding the scope and context. And in the collapsed mode, you simply rely on the Cassine similarity between the query and those chunks. At least that's what I understood.
So there is one, like, I think very key missing picture that wasn't described here. So the way they essentially package, so imagine this first layer of your leaves are just like text chunks. You chunk whatever information you have there. What they do on the next level of summarization, they actually cluster those chunks as a Gaussian mixture model. And I'm sensitive to this topic because I was doing research. I have a paper related to Gaussian mixture models. That's I got super excited by this paper. So basically, you have leaves, it's just text chunks. Then you group chunks together according to some, like again, your cluster, like parameter-based clustering. Now those clusters, you group together, summarize them, and now it's your new layer. Essentially, it's your like branch. And then you can do it multiple times to build the structure, tree structure. So in a sense, I'm excited about this paper because if you think about it, if you do this, so on some level of the tree, you will have information propagated from different documents all the way to the top. So in a sense, you have this process of getting like entropy added to the system, if you will. So that's why this approach should work really well. And I think if you dive deep into this stuff, you will kind of notice that at some levels of this summarization, you will have better results than you expected because you kind of have this grouping of unrelated documents on that level and so on. So I'm actually excited about this one, and I really want to kind of implement some experiments on top of this one. Just kind of quick thoughts here.
So kind of, if I understand you correctly, so basically you kind of like you retrieve all the chunks that is related to your question, and then you summarize kind of the chunks, and you kind of continue doing that until you kind of get to one final smaller size chunk that is kind of very condensed, but it kind of captures all the information you want.
Except it happens like before the actual query. So there is a data engineering that happens with the composition of this tree, and then you make querying on top of it. So let's say we have a research paper, right? The RAPTOR research paper. We split it in chunks, and then we cluster those chunks in terms of which are the most related to each other conceptually, semantically. Then we start compressing them hierarchically, and we produce, like, if we run it in infinite time, until one sentence collapses, it's pretty much just one sentence that describes all the concepts that are present in those chunks. So then when we have a query, we can either start at the very high level or at the very, low level. And what they propose is two techniques, starting from the highly compressed view and then traversing deeper, or pulling from the entire flat pool of all these summarizations and chunks that haven't been summarized.
So is it kind of like a shallow summary, very simplified, that you can dig into, or everything is simplified and you can just scan through the whole thing?
Yeah. So digging is probably the simple version of explaining this technique was the tree traversal. Like you find the most relevant, the most compact concept, and then you keep
And
digging.
you unpack it a bit. You unpack it a bit and go and you get a bit more, and then you unpack a bit more and you get a bit more, and you expand as you dig through that concept.
Yeah, and what you dig through
and broaden
is
it.
that compressed, chunking. And as you dig further, it uncompresses itself. Very interesting and very practical. I would say it's a little bit complex. Like it's not as easy as adding noise to your prompt. But yeah, I would also love to play around with it.
Well, then like what excites me here, because usually when in research, when you kind of focus on this specific domain, right? You kind of like, hey, how I could, I don't know, do clustering of my high throughput sequencing data reads or something. But then you simply saw in papers published for some very unrelated vertical, and then see some technique and like, hey, I can use it for my data as well. And this is how you get
you stitch
easy
different
published
ideas
data.
from different, you get stitched
Yeah.
different ideas from different versions or different specializations. You go, I'm going to take some of that and take some of that and take some of that and create a new approach from blending ideas.
Right, exactly. And then like how, like for example, like if we build an agent, how actually all of this would happen. With this technique, you can kind of clearly see how it will happen, right? At some point, let's consider this archive of all papers. And our text chunks are just like, again, straight paper. And if you do everything, then you kind of like on the one level, okay, here is summarization, your abstracts. But what if you do like another layer of our tree, right? You will kind of group all of the papers together. And let's say at some point you will have a branch that is like, it's AI, this is applied math, this is like physics. But then at some point, like all of those, like if you do hierarchical clustering, then it will be kind of like still in the different sections. But with this technique, when you will have chunks of paper, they're going like, hey, wait a second, these are related. So they will be grouped into some branch that is like node in the tree that actually is all tied together. And now you will have this process of LLM kind of starting on the high level. Oh, this is the question related to like math. Boom, it's here. Applied math, AI, and eventually it will get to these chunks that are actually kind of, oh, this is from physics and this is from RAGs. And now we're combining it together and it all makes sense. So this is how like knowledge get discovered, at least.
Yeah, I was going to say this sounds like the idea when we've talked about knowledge propagation and understanding how knowledge is connected to other knowledge and the web of way into. I mean, like if you looked at my digital book library, the way I tag things, sometimes it's the same sort of thing. Like some topics are both psychology and business. Sometimes it's one, sometimes it's the other, but they could be both. And if you were looking for something through psychology, you might end up in a business idea because business is based on psychology. It is an example of like, because I read a lot on psychology related stuff.
Right, and you cluster and then you summarize it.
and basically I just manually do this right now. I need to work out how to do it in a more efficient way.
Exactly.
Well, the more efficient way is just to build an agent to do all of this.
Yep, exactly.
Just throw the entire library through it. Thanks. Yeah, cool.
Yeah.
So basically the idea is to have a browser on top of this retrieval. Like different levels, whatever LLMs does here, it'll be great to see actually like the documents and just visualize all of this stuff. That'll be a cool project to do.
Yeah. And just because we're already past the hour, I'll skip to the next paper. And maybe I'm not sure, like, do any of you have to leave? obviously we'll record this, but you know, for the live engagement.
I've got another call soon, so I'll
right.
leave before that.
All right, we'll speed up a little bit, but good to know that probably 2 papers or 3 papers is the limit for these types of discussions. All right, so the next paper, the CRAG, also interesting technique and engineering solution that is proposed in here. It's basically building a solution inside the retrieval mechanism to be able to improve the accuracy and create the dynamic response in a way. So what they propose is on a step of the retrieval, creating a retrieval evaluator that is judging the documents if they are actually relevant and correct in response to the query. So they have the concept of correct, ambiguous, and incorrect. And obviously for ambiguous and incorrect, they propose additional layer of searching. And for the sake of the research paper, they just used, browsing the web for it. But for the correct, they have the knowledge refinement and decomposition of the facts, then filtering and recomposition into like the most relevant context possible, which is where it totally contradicts the first paper that we were talking about, because it's all about creating the most relevant context within the query. So it's fun. I've definitely read this and I was like, interesting, like totally opposite. But yeah, would love to hear what you guys think.
My brain's going back to our previous discussion. We were talking. I sort of used it as the idea of it, making the space bigger so you can hit it, and then correcting as you approach. This is like using a telescope instead. It's like, rather than trying to work out if you can hit a bigger space, it's just going like, why don't I just give you the ability to look even closer to make sure you're aiming at the right thing, and using as much information in front of you to work out, yep, that is definitely the right thing you want. So like one's a telescope and one's like, make the whole thing bigger and use it as you get closer. That's how I'm thinking about the 2 different approaches. It's interesting different ways. I mean, I can't see why both of them couldn't exist simultaneously, but it probably computational limits is probably part of it.
A couple of things that pop to mind are both, it would be really interesting to look at the best ways to try to research and evaluate which are the situations in which these different approaches are the most relevant or most optimal, both in terms of what the source material is and the kinds of questions being asked, as well as how it's getting processed. That strikes me, just to meta for a second, to say that seems like the kind of thing that a group like this could be really useful for, where for any of our different organizations where that's a relevant question, maybe they would be interested in co-funding that group of people working on that problem, so that each of those organizations benefits from having a clear answer as to which of those approaches might be suitable for their domain net approach.
Yeah, I agree. Here it's all about experimentation with this type of thing. And again, like how you design the experiment, because it essentially, this paper is specific implementation of this ideas of like, wait a second, if we add like even wrong stuff to context, we just maybe fix entropy collapse issue and then it works, right? Or, like, so this essentially, we're starting to get into this territory of it all highly data dependent, use case dependent, etc. So the question is like, who oversees the experiment here, and like what are the best practices to do stuff like this? But otherwise, it's kind of like very interesting to have the best retrieval possible, the best scoring, right? This is how my recommendation works. Versus, okay, the data is not that great, but my scoring is like the best, super tight, and then here's my result, and stuff like this. So again, very interesting to experiment with.
What is not very clear, how they do knowledge refinement. And also I would say in LM, what is missing is time dimension. So you don't know so in this case, who was the screenwriter for Death of the Batman? And what is that? Is it book or movie? Or you don't know, right? So you should ask more questions, or you should get this information from context. And probably it will change if someone will make movie called like that, right? So how they're going to establish this ground truth and to do this knowledge refinement?
One of the pieces just related directly to what you're talking about, Slava, there that this is for another time, but that conversation around the interrogatory process for AI agents so that they can get that bead on the correct context from the user is a really interesting, relevant area to dive into.
Yep. So obviously all use case dependent, and I think the biggest challenge that we observe as practical implementators is the fact that all of these research papers definitely produce some interesting ideas. They're so, detached from the real world applications that the only way to, create some validity and verify works is to actually experiment on real world problems. So that's why, this community has even more value in just that, trying to replicate the results for real use cases. So unless anyone else wants to go on the CRAG, I'll jump into the survey paper on agents. Super interesting paper, covers all of the main topics and concepts that we've been observing and kind of like reading and trying to create solutions for. Me, personally, I've dealt with that in the context of actual production implementation of LLMs, and some of these concepts are still unresolved. Like we see some solutions popping up, like MemGPT that got released just this week, that attempts to solve the memory issues for agent-like experiences, and it's still, a huge problem that no one resolved. Obviously, in a way, long contexts help us on this journey of solving for the memory or lack of memory, and then everyone just tries to compress the previous interactions into some form of memory. A lot of companies are trying to create abstractions like LangChain and Llama Index and others. And MemGPT, in a way, is also creating an abstraction to work with memory on a high level. So super interesting. Obviously, we're still super early in this agent space. That's why, this paper is of pure, I would say, kind of like observer type of knowledge. It doesn't produce much actionable technique or something to test or verify, but nevertheless, super interesting. Anyone has any thoughts or discussion points?
Just an overview paper, like I actually find it like very hard to read after the previous three, because it just get too much of like not necessarily very related knowledge, right? Because again, overview paper. So that's why it's hard to kind of like, okay, what to discuss. There are so many possibilities.
Right. And what we can do is actually try to jump into the Q&A section. So the idea behind the Q&A section and the vision for the future sessions like this would be for an AI agent, the research agent that we would create as a community, to produce the types of questions and reflections for us to have a productive discussion in relation to the papers and the use cases. So in a way, I envision, let's say some teams will work on the healthcare applications, some teams will work on financial applications, some on educational ones, and we'll absorb that knowledge into our own, community system, and we'll be able to then, pull papers, digest them as, as an agent. It would recommend some papers and, produce some questions like, hey, maybe this RAPTOR thing is relevant to this problem. So the Q&A section that you see in the document, I'll resurface the document once again, is something that we've generated through LLM, and wanted to basically have a more productive discussion. But before we jump into Q&A, maybe Anton, you want to screen share, just a quick showcase of what we've got so far in terms of the, our vision to have some form of a product on top of this. So you should be able to share a screen.
Yeah, I think I should be able to do it. So last week we kind of launched our first, I wouldn't say it's a RAG agent. I'll just call it just like a bot that reads papers on AI topic from archive, and then you can essentially pull relevant data. So I'll just post it to link PolyAgent Streamlit app. Now let me share my screen. Okay, can you see it?
Yep.
Okay. So this is the link PolyAgent. Now what we have here is very simple process. We pre-processed all of the archive .org papers that are on the topic of computer science. I think it's something like this. So CSAI or something like this, and you will pull all of the relevant papers. So essentially, we had a bot that sniffs through it, read title, authors, abstracts, and then compute embeddings on it and start in a essentially vector search database. So we use MongoDB because MongoDB has some support for organizations. And now what we can do is first pull relevant top 10 papers related to your scope of interest. So let's say we're interested in entropy collapse. And it will pull some relevant papers. So this first response is simply vector search. So essentially no LLM action whatsoever. But at this point, to the context, we got 10 papers, including their abstracts. And then afterwards, we got LLM based on Mixtral agent to simply go through abstracts and relevant to our scope of interest, picks up the paper for us for review. And in this case, for example, it suggested us this large language model evaluation via matrix entropy and why it made that choice. What is interesting here is, can I see it? No, I think it was some different example. So we could try something different, like Gaussian mixture models, and it will also pull some papers for us, and also we'll choose a mixture of experts, for example, as most relevant one. We can do an interest in CRAG application of entropy collapse, something like this. And it's supposed to be more relevant. Oh, you see, for example, CRAG paper showed up here in the context, and so on. So again, not a lot of agent functionality, but a good baseline to start to essentially build all of these different techniques that we discussed earlier today. So as I said, the link again, post it in the chat. So play with it and give some feedback. Then the code for the Streamlit app will be posted on our GitHub repo for PolyAgent organization, so you can run it as well. The only thing is you will need a key to database, etc. We'll figure out how to deal with it on case-by-case basis. Let me stop sharing. So yeah, we that's kind of the goal. Maybe if anyone is interested in working on some of the techniques that we just discussed, just pin me on Slack and we'll see what can we do, what kind of app to build or something like this. So it'll be cool kind of activity to do between our paper review sessions.
Yep. So maybe for this Q&A session, we'll just skim through these questions, and then we can take this asynchronously. So we can think about each of those and maybe come back and discuss it in Slack. But basically, what LLM produced was a suggestion to use RAPTOR for, review papers for our use case. Then what sources might the agent retrieve beyond papers, web, books, and docs? How to determine the relevance. So that's in relation to having multiple agents that are specific to different modalities. Then could the agent generate customized summaries around themes like RAPTOR? Useful for teams? Probably a good, experiment. How might recursive abstraction help identify trends across literature like RAPTOR does? Also interesting, because as the side effect of these summarization techniques, we may stumble upon some trends that may not be obvious, but happen across different papers. And then all of a sudden, boom, we have, some chunks that are summaries of these trends, and then agents or us can spot those. What role could specialized sub-agents play in facets like citation analysis? So this is interesting in terms of traversing the actual graph of citations and figuring out where the knowledge exists for a given topic. Would reasoning capabilities allow for adaptable recommendations? Also interesting, and this is more on the mode of engagement with agents within the community or during the paper sessions. Then how could the agent collaborate effectively with researchers? Also very interesting topic to research in terms of, is it, Slack messages? Is it a web interface? Is that, specific emails that we send as queries? Like something to think through. Then CRAG method improves robustness when retrieval goes wrong. Could it help make agents more resilient when accessing unreliable information sources? Also very interesting, because we may stumble upon some research that is not, not replicable or invalid. After all, we're dealing with so much research coming out that,
well, that's like Slava mentioned, isn't it? Where there could be 9 points that are actually accurate, but somehow the summary doesn't actually summarize it very well at the end, or the conclusion could actually not infer what other people seem to take from it. So yeah, it could be a case of like parts of papers are good and other parts of them are,
or maybe someone
off.
faked the results.
Or they just,
Yeah, also could be possible. CRAG uses web search to find complementary external knowledge. Could this help agents gather information from more diverse sources beyond static corpora? So going beyond the archive data set and actually crawling the web. And the last one, the retrieval evaluator quantifies confidence in the retrieved documents. Could similar confidence estimates help agents determine source reliability? So kind of like on the same topic. If we, if we can assign the confidence to these results based on the sources, like eventually we'll start noticing that research that is coming out from, I don't know, Vancouver or Rome, is more relevant or more, replicable or more researched given the specific topic or direction of research. So I'll share the document with everyone who attended the call. And yeah, hopefully this was exciting. Definitely was for me. Looking forward to the next sessions and connecting with you in Slack. For those who is listening to this call and has no clue where the Slack is, you go on our website, polyagent.co, and you submit your application. We'll get you onboarded, give you the access to Slack workspace, and that's where the magic happens. So just to wrap it up, I don't know, Daniel, Anton, Tyler, you want to do some closing words?
For me, it's exciting to see everybody coming together, kind of colliding. The Q&A is fantastic. The different ideas it's sparking. I can see the value in these sessions, and that we're just really looking forward to talking with everybody to figure out what are the different ways that we can collide, gather, meet, and work that are going to be most beneficial for everybody in the community. So yeah, thanks everybody for coming.
Yeah, my sense, I'm super excited to see so many interest like from the get-go. So it's super fun. I would really like encourage people to come up with their like own use cases, what they're working on like right now, to bring to the community to kind of build some experiments on top of it. Because one thing is to take a paper, get excited about it for some reason, and then kind of, okay, so what do I do with it? Like, where can I apply it? A lot of people have this type of troubles. For example, like I definitely have. So definitely let's search for interesting use cases to bring also here, and then maybe merge with some interesting like published research and see what we can do with it.
Yeah, it's that
So, yeah,
integrating
super excited.
theoretical knowledge and project-based learning, because project-based learning is the thing that cements most people's understanding. So having projects to integrate and understand and learn from other people's knowledge is peer-based learning is normally the most effective way I find. So I'm looking forward to hearing from you guys. And yeah, lovely to see everybody again. Lots of familiar faces. It's been a while.
Awesome. Awesome. All right. Have a great rest of your day, evening, night. Thanks again for joining in. Bye-bye, guys.
Thank you, guys.
Great, nice discussion. Thank you.
Thank
Take
you,
care.
guys. Interesting.
Thank you.
Bye-bye.